Okay, hello everybody. Welcome and thanks very much for joining us today for this AFN Network Plus webinar on methane, muck and money. Are we missing a trick with manure management? So I'm Jez Frenberg and I'll be chairing today. I'm based at the Tyndall Centre for Climate Change Research at the University of East Anglia, where I'm the Knowledge Exchange Fellow for the AFN Network Plus. If this is your first webinar with us or interaction with us, then just to let you know, AFN is a £5 million UKRI funded project focused on identifying research gaps that could help reduce emissions in the UK agri-food system. We currently have around 1,600 members across the UK, so please do join us if you haven't already, and I will put some links in the chat shortly. So on to today's topic. For a while now, most research on methane emissions has focused on enteric emissions, i.e. directly from livestock themselves, because government figures show these account for the majority of agricultural methane emissions. But our two speakers today will be presenting on research in progress of growing evidence from field measurements that suggests the UK may be underestimating emissions from manure and slurry by a significant factor. So they'll also be presenting research in progress on how this could be turned into a useful source of energy and income for farming businesses, and how significant the monetary value of this might be. So our speakers today are Professor Andy Atkins and Professor Neil Ward. Andy is the Chief Scientist at the International Fugitive Emissions Abatement Association, a not-for-profit working to accelerate action to reduce fugitive greenhouse gas emissions. He's an engineer and innovator and has detailed technical knowledge spanning all sorts of fields, and he bridges the gap between product development and applied science in academia and industry, and has over 50 patent families to his name. He holds visiting professorships at Loughborough and Portsmouth universities. So Neil, you might have already met Neil. Neil is a co-convener of the AFN Network Plus and a professor of Rural and Regional Development in the School of Environmental Sciences at the University of East Anglia, where he was previously Deputy Vice-Chancellor. He was previously Director of the Centre for Rural Economy and has also worked for periods on secondment to the Cabinet Office and as an advisor to the Economic, Social and Research Council. His latest book is Net Zero Food and Farming, Climate Change and the UK Agri-Food System. So I will hand over to speakers in just a second, but if you have any questions as we go along, please write them in the Q&A panel. We'll have about 30 minutes at the end for questions. Feel free to use the chat for discussion and sharing relevant links otherwise. We are recording the session and we'll be putting it on YouTube later on for others to see. It will be public. So if you don't want to be identified for any reason, probably best not to ask a question or do so anonymously. So over to Neil and Andy. I'm not sure who's taking over first. If you can, unmute and start your video.
I'm going first, Jez.
You're going first. Okay, great. Over to you then, Neil.
Okay, thanks very much, Jez, and hello everybody. Andy and I have divided the talk up into 4 parts, and I'm going to do the first 2 and then hand over. I'm just going to cover the significance of methane as a greenhouse gas and agriculture as a source of methane, and then talk a little bit about how we calculate and estimate methane emissions and some questions that are emerging in the international scientific literature around this. And then Andy's going to go on to talk about some local work we've been involved in down in the southwest and the potential value in acting to capture and utilise methane. So that's the plan. I just wanted, by way of introduction, to just sort of say we've been going for about 18 months now with the AFN Network Plus, spending a lot of time talking to people, workshops, reviewing the literature, thinking about the research landscape around the net zero transition for the UK agri-food system, and where there might be gaps or key sort of problems and issues to address. And we're very much driven by the question of emissions reduction, net emissions reduction. So it's the transition to net zero by 2050. And so quite an interest in what's most material, what are the biggest sources, what are the biggest actions that can reduce emissions. So quite a complicated set of issues around the UK agri-food system, a real diverse sort of set of interests and research questions, but some things are more material, some things are less material. And this particular issue, I've been quite interested to pursue, working with Andy and colleagues at IFEA, because it feels potentially quite a material and quite significant issue. So in terms of greenhouse gas emissions, the agri-food system is about 23% of UK emissions. Agriculture is around about half of the emissions from the agri-food system, so 10 to 11% of total UK greenhouse gas emissions. And emissions from livestock are quite a significant proportion of all agricultural emissions, upwards of 60% probably. So it's been quite interesting to work on this issue. And I fear very much come from a starting point of working to reduce fugitive emissions, and particularly emissions from methane. So if we just turn to think about climate change and methane in general, and I'll ask Andy to move on to the next slide in a minute, Andy, but hold it for now. I just wanted to say, if anyone's interested in reading around this issue in a bit more detail and really up-to-date sort of an authoritative analysis and discussions about global warming, methane and the UK situation, then the House of Lords are conducting an inquiry into this at the moment. It's the House of Lords Environment and Climate Change Committee. I think Jez was going to put a link in the chat, possibly. And I'd recommend people go and have a look at that. There have been a couple of oral evidence hearings already, and you can read the transcripts, and I think you can view videos of the sessions as well. So there's some really good discussion, and there'll be more coming online from that select committee in the coming weeks. So if we move on to the next slide, Andy. Thanks. So lots going on this slide. Don't worry about grasping all the detail here. Suffice it to say, we're at about 1.25 degrees above pre-industrial temperatures for measuring global warming. So we're in quite a sort of serious position. Globally, the temperature seems to be rising at around about 0.25 degrees C per decade. So it currently looks like we're going to break the 1.5 degrees target very soon, probably within this decade. And within the sort of pattern of emissions of different greenhouse gases, methane is rising steeply. So the graph on the right shows that emissions of methane are rising quite steeply, so it's an increasing challenge. Methane is the second most significant greenhouse gas after carbon dioxide. And so if we're going to keep below the 2% target within the Paris Agreement, we're going to have to stop methane emissions growing at the rate they are and get them to level off and ideally come down. Methane is much more warming than CO2. But it doesn't persist in the atmosphere for so long. It breaks down over time, whereas CO2 persists for much, much longer. So cutting methane emissions is a really important part of the net zero challenge. And it brings a double dividend, actually, of reducing greenhouse gas emissions, so reducing the warming that's going on in the atmosphere, but there are also benefits in terms of improving local air quality as well. And reducing methane brings quite a quicker response in terms of reduced warming than cutting CO2, which sort of is cumulative in the atmosphere. So if we can move on to the next slide, Andy. Just wanted to say a bit about how we calculate emissions from agriculture and livestock. And we follow a system that's been devised by the IPCC through several waves and refinement. Methane comes from two sources around livestock. It comes from an enteric fermentation, so that's coming directly from the animals themselves. It's mainly burps, as I understand it. It gets talked of as burps and farts, but it's mainly burps. And then secondly, from the manure management, from the storing and spreading of the dung, the manure or the slurry from the livestock. The amount of methane that comes from farm animals varies across different livestock types. It's particularly cattle and to a lesser extent sheep. And if we take, say, for example, dairy cattle, then the UK National Inventory calculates that around about 3/4 of emissions come from enteric fermentation, and around about 25% of emissions from dairy cattle come from the manure management. So it's about a 3-to-1 ratio with dairy cows. If we look at other livestock and other cattle, sometimes the ratio might be as high as 85% enteric fermentation, 15% manure management. So enteric fermentation is seen as the bigger deal, manure management sort of 15 to 25%, depending on what sorts of animals. Now, the IPCC framework for how individual countries might estimate what their methane emissions are from agricultural livestock divides into 3 different sort of tiers of analysis. So the first one, tier 1, is the simplest approach. You get these average sort of global statistics on emissions by type of animal, and then you put in data about temperature and a few other factors, and you can compute a sort of an estimate for your national herd, and you can calculate it that way. So that's most simple. At the other extreme, tier 3, the system is based on field measurement and sophisticated models. So that's the most elaborate and sophisticated. And in the middle is a sort of intermediate approach, which is based on some generic statistics, but weighted according to quite detailed data on different types of livestock, the types of manure management systems that they're housed on, and so on. So it's a sort of intermediate approach, and that's quite common. And the UK follows a tier 2 approach for estimating emissions from manure management. It's more expensive for a country to use tier 2 or tier 3. It takes more data and it's more sophisticated approach. Tier 1 is the simplest. But if you look across national inventories internationally, then you find that if you move from tier 1 to tier 2, your calculations of emissions from livestock do tend to go down. So the more sophisticated the data that goes in, the more likely it is that the calculation ends up being a lower amount of emissions. Under tier 2 is quite a complicated formulae for manure management emissions, methane emissions from manure management. So it calculates, you have the number of animals, you have what they're fed, how they're housed, and there is a methane conversion factor, which is a sort of discounting factor. So you calculate what the total sort of potential emissions if all methane was emitted, and then that is reduced by a methane conversion factor, which you could think of as a discounting factor. You can see in the little box there, there's an example of the equation for calculating methane emissions from manure management. And you can follow this all up in the national inventory, and these tables are taken from, I think that table is taken from the IPCC guidance. So if we can move on to the next slide, Andy, which I think is my last slide. So we started to just look at the UK data in comparison with other countries around the world. And the first thing you find is there's quite a lot of variety around how much methane is calculated to be emitted per head of different types of cattle per year. So the bar chart there shows methane per head per year, with Japan at the far left, and then Denmark and Canada and the United Kingdom. It goes through Spain, Finland, and you get along to the right-hand side, Slovakia, Romania, Belarus, etc., etc. So quite a lot of variability in how much is estimated to be being emitted per head. The orange bars are average national temperatures. So that's put there just to show that there doesn't seem to be a strong relationship, simple relationship between temperature and emissions per head. It's to do with other factors. Now, that prompted us to look at the international literature on methane emissions from cattle and looking at manure management in particular. And we find that, well, first of all, the IPCC's framework is based on science that is quite old, 1990s science, but that based on measurements initially carried out in the 1970s. And over the last 10 years or so, there's been a relatively small number, but a growing number of studies being published which are asking questions of this framework around manure management in particular. I think it's fair to say that generally, field monitoring endorses the approach that national inventories use to calculate enteric emissions. So there's not a lot of questioning or controversy around the enteric emissions coming from the animals themselves, but there is a little bit of questioning of whether the assumptions are correct around how we understand how much is coming off of slurry pits. So in 2014, there was a global meta-analysis conducted which found field scale measurements were of the order of around 3 times higher than the modelled emissions that are included in things like the Tier 2 methodology. There's some evidence as well, methane scientists looking at the difference between field measurements and the sort of top-down environmental monitoring where you just take samples of the air and see how much methane is in the atmosphere. We have a national network of methane sort of monitoring stations. And can you reconcile, you know, what we find when we just sample air, see how much methane is in it, and these sort of modelled estimates of what might be coming from different sources. And there's, you know, some interesting science to be done to the extent to which those things match up or don't. Next slide, Andy. We found a PhD that was conducted in Canada. I think it was 2018 it was published, which measured the emissions from a covered slurry lagoon over a 1-year period. And it suggested that the discount factor that was being used should be of the order of 0.45. In other words, around 45% of the possible methane that is being produced is being emitted, and
Neil seems to have disappeared. Andy, are you at all able to take over from there? Because Neil seems to have disappeared.
Yeah. Can you hear me?
I can. Oh, Neil's back. You're back now.
Sorry about that. Hopefully that was just a pause for people to be able to digest some of the text on this Canadian slide. So the Canadian study is calling into question the high levels of discount factors in national inventories. And there's a series of other studies that have been published of local fieldwork in California and in Denmark, all contributing to a questioning of the calculations produced using this IPCC standard sort of international approach, which is widely adopted in national inventories. So I'm going to stop there and hand over to Andy.
Thank you, Neil. So what we've got is some data from one of IFEA's members, Benham down in Cornwall, who very kindly allowed us to interrogate the data that they're getting from their slurry pits that they're covered. And I've anonymised two farms, and the left-hand data and the right-hand data is the same set. So there is rain, air temperature, etc., going on farm one, but I've removed it on the first one for clarity's sake. What that's saying, so what we've got on that graph, we've got the mass of methane being produced, the air temperature in the location is in the pale, and then the dark blue is the amount of slurry. So basically inputs and outputs of slurry from the actual pit. Now, the first thing is the IPCC calculation is underpinned by air temperature. And the first thing that becomes fairly apparent is that there's very little correlation between air temperature and amount of emissions, something the Canadians saw as well, that temperature acted as a switch, and it was largely down to ground temperature rather than air temperature that was the driver. And we're seeing an average of about 145 kilos per head per year. That's against a UK reported figure for dairy of about 38. So there's significantly more. Then we went to farm 2, and in this we were looking for other correlation factors. So we got solar load on there and we got rain. And what you can see is that when it rains, the amount of emissions drop with a lag, largely because we believe that it's taking the heat away from the slurry. Bear in mind, the water's not going directly into the slurry in this format. And then solar load, and basically is when the solar load goes up because it warms directly the top surface of the pit and the ground, then that drives emissions. And for pit 2, we were seeing about 198 kilos per head per year. So what we want to do is see whether those figures, which correlate quite well with the Canadian study, correlated with other data sets from around the world. So this is part of the data mining operation that we did, and we were checking enteric, and this basically showed that, yeah, enteric basically follows what you're seeing from the IPCC calculation. But in general, two things came out. One, that covered and uncovered pits seemed within reason to be given very similar amounts of methane, though there seems to be there's a need for a lot more work on that. And secondly, that in general, the amount of methane coming off these pits is considerably higher than the codes that are done. So then we basically started thinking, well, what's the impact of all this methane if we're not calculating it and we continue to put it into the atmosphere? So we looked, we went into, we built a model on this, and you got the left-hand graph basically is showing the dotted grey line at the bottom is what you would have between now and 2050 in terms of temperature rise as a result of the methane that we're claiming in the IPC returns into the atmosphere. And then the green dotted line would be if the effect of stopping them with time. So if we were to stop them today, you would effectively reduce the global warming temperature by 1 year's worth of growth. And that's using the GWP figures from the Royal Institute of Chemistry. So a very significant impact if you reduced all the methane coming out of the European herd. And if we take that back, you know, what are the impacts? So we've talked about the CO2 and the temperature rise of the globe. But there are also financial impacts. This is an opportunity. This gas is coming out in a dense format in a known environment which can be collected. So that would lead to direct social money going into currently quite poor rural communities, which will give you social benefit. Also, the methane escaping into the atmosphere does have direct health effects. So you've got a health environment in terms of global warming and social benefit. So if we took 157 kilos per head per year with 100 head, that's equivalent to 24,000 litres of diesel, which at forecourt prices is worth about £38,000. The equivalent of displacing that diesel then is 64 tons CO2. So you've got a net reduction of 21 tons because you're still burning the methane. However, the GWP impact of that methane not going into the atmosphere as methane, but as CO2 is 1,884 tons. So the net saving is nigh on 2,000 tons in the first year. So quite a big impact. So in terms of summary, what we're seeing is that the enteric emissions are pretty reasonable. A lot of work's been done on that through the IPC, so you'd expect it to be. But there's general evidence coming both from measurements being taken within the UK by people working in that space, that these emissions are being underestimated, which is supported by global efforts, and that air temperature is not a good indicator for the amount of methane being produced, but solar load, water, rain, for example, seem to be better indicators. So the discounting approach inside the IPCC calculation, the fundamental maximum amount seems to be good correlation, but it's the discounting approach that seems to be the core of the issue. And that if we can capture these emissions as they're coming from situations which are both dense and localized, they could be, you could turn a vice into a virtue, which would give economic, social, health, as well as global warming benefits. I think at that point, we've come to the end of our presentation.
Brilliant. Thank you both. If anyone has a question, please whack it in the Q&A panel. I know there's a lot to cover that and kind of digest and everything. I'm wondering whether you sort of mentioned Canada and sort of evidence coming out of Canada, but where else is this evidence coming from? So you're kind of saying that other people are starting to look at this a bit more. So who is looking at it, and what they're finding sort of comparable to what you've been finding in the UK?
Excuse me, yes. There's a lot of work going on in the States, for example, and they are seeing similar answers. There's a lot of work going on in California at the moment. They're using drone measurement techniques to create local maps. The Danes seem to be doing quite a lot of work in this space as well. Really, what a lot of these people are beginning to see is that we should be driving much closer to a tier 3 approach rather than a tier 2. That the tier 2 is a little bit potentially inaccurate. So we either need to massively refine tier 2, or you'd be better off going to a models based on your own data, which is the fundamentals of the tier 3 approach. What's
the sort of practicality of the tier 3 approach? Because it's very much collecting in-field data, isn't it? How much data would you have to collect to be certain enough of the overall national picture? I think if you built, as more and more data is collected from different environments, you could refine the tier 2 approach, and the tier 2 approach would then give you a lot better results. How much data is enough?
I don't know yet. I guess we don't know.
I think that the work that we've been doing does help sort of raise the profile of this as a research question in the UK. So I think it would be really useful to be doing some more systematic work. Those two farms that Andy presented were in Cornwall. Is there something about the local environment or local conditions, or is it to do with, with the way the animals are fed, et cetera, et cetera? There's a whole load of questions that we could get more information on if there was more of that monitoring done in a wider range of contexts in the UK. So there's an obvious research agenda that comes out from that.
Some of the anecdotal evidence coming from further up the country is that you're getting just as much methane off those sites as well. But the local environment has quite a big impact. If you've got rock which absorbs a lot of heat and stays hot for a long time underneath your ground on which your slurry pit's built, it will stay hot for a longer, so you're less the environmental air temperature will have less impact. I think that the big problem is a lot of this is going back to very early studies which only looked at air temperature. The tier 1 approach is only air temperature. In fact, solar load seems, from the Canadian study, that the solar load seems to be as important, if not more important. Also, length of time that the slurry stays in the pit is a big impact. So there are all sorts of different aspects.
There are essentially all sorts of factors that are not being taken into account then currently by the current sort of tier 2 calculations. Yeah. Starting to get some questions coming in from people. One from, I've got quite a lot coming in suddenly. Hang on, there's one from Liam at the Green Alliance. What fraction of methane emissions from slurry stores can be captured, e.g. by the technologies pioneered by Benjamin?
That's another piece of work, how much is actually leaking, but it's in the interest. I think that's the interesting thing is if you turn the slurry and the emissions from the slurry from a, if you like, a pain and something you have to do it into a revenue stream, it's in everybody's interest to make sure you, A, keep the slurry in the pit, which is good from the point of view of water pollution, et cetera, and B, then capture as much as you can. In the end, I think that the reality is that the pressure under the covers is fairly low. So you're not going, if the leaks are high, the flow rate out isn't high. But the bottom line is, even if you only catch 98% of it, you've caught 98% of it. So you've reduced the GWP by a huge amount. So again, more evidence from a research point is there, but it becomes economically attractive to catch as much as you can, so people will work towards that. So as I say, you've turned a vice into a virtue.
Yeah. Quick clarification from somebody here. They just want to know, does this research cover solid manure as well as slurry? Is it both?
Currently it's for slurry, but solid manure would be looked at as well potentially as we go forwards. I saw earlier there was a question about porcine and other animals. We've currently been looking at dairy and slurry pits for those, but there is we're aware that there's a lot of gas coming off other animals as well. I mean, people should look at horses as well. I mean, the horse's digestive system's half as efficient as a cow, so the volatile solids in the back end's twice as high. They used to heat pineapple sheds with the rotting processes of that. So I think, yeah, it gets expanded, but you have to start somewhere, and a detailed study of this. And if we can raise the profile of this, then extending it to other animals becomes a natural approach. But there is definitely huge potential in pig, and maybe even things like chicken as well.
If you
can I come in, Jez? Yeah. I mean, I think the other significant implication of this is that ratio of sort of 4:1, 5:1 enteric versus manure management has sort of cast the manure question as a bit of a sort of Cinderella question when it comes to methane emissions from the livestock industry. If you look at the Food and Agriculture Organization did a big report on methane I think it was last year. Massive report, very interesting. It got 5 times as much stuff on addressing enteric emissions as it had on addressing emissions from manure management. And if we were to take these 2 Cornish farms as representative, and that's a really big if, I think they just opened up a set of research questions to start with. But if those proportions were writ large, then it would look more closer to 50-50 rather than a sort of 3-to-1, 4-to-1 ratio. So we would hope that the implication would be that there would be much more scientific effort and policy discussion, and there would just be a higher priority to be thinking about how you can address these emissions, as well as the feeding the cattle seaweed and all of the other things that are gaining all the attention around enteric emissions. So it rebalances the sort of priorities around enteric and manure management.
And to pick that up and extend that argument, if you ignore the system aspect to the back end of the cow, if you change what's going in the front end, what's coming out the back end changes too. So you might see less benefit than you thought by changing the feed if you're not aware of what's going on at the other end.
Okay. This is kind of feeding into a few questions here then around economic mechanisms that could be used and existing infrastructure. So how easily does using methane as fuel fit into our existing infrastructure, and what would need to happen otherwise? And then there's questions around what would be, what kind of economic mechanisms could help to encourage capture. So I guess this is around sort of policy changes and government intervention and things like that.
I can chip in to start with, Andy, if you like. I mean, I think one of the concerns I have around this, so I right at the start of my career, I worked on slurry for several years, starting in the 1980s. And it was all about the water pollution challenge of, principally it was then around water pollution incidents from livestock farms. We've become much more concerned about diffuse runoff in recent years, but back then it was about point source spills and catastrophic failures of stores and things like that. We still have an enduring water pollution problem from livestock farming, even sort of 35, 40 years later, after all of the attention in the 1980s. And there's a challenge around ammonia as well, and sort of local air quality issues. So I think one of the challenges here is to think about slurry management from the perspective of managing water pollution risk and local air pollution and greenhouse gas emissions in the round. And I think the problem on the policy side has been that you traditionally tend to have slightly different people thinking about water and thinking about ammonia and thinking about greenhouse gases. And so there's a challenge in bringing that together. There are grants, capital grants for slurry equipment, but for capturing the methane, there's quite specific things that would need to be achieved and done that you wouldn't require for managing the water pollution risk or even the ammonia risk. So that those things have to be looked at in the round, those 3 different types of problems, because a single solution could help with all of them.
I mean, how do you, given that the research has focused much more on enteric up until now, and the sort of, I guess, government sort of thinking around it is focused on that, do you see it as do you think it's going to be quite difficult if the evidence does mount? Is it going to be quite difficult to kind of shift that perspective more towards manure? Is that a sort of entrenched sort of belief, or is that something that would evolve, do you think?
I'll have a go at this, and then Andy, you might want to come in after me. I mean, I've heard it said that this is an issue which isn't a sexy one for sort of politicians and policymakers to get involved in. So it suffers its sort of Cinderella status, not just from the perceived sort of ratio between enteric and manure management, but because there's something rather distasteful about spending all your time thinking about manure management. I don't know why people feel that way, but anyway, there's that. But I think the critical thing here is there's an economic value to be exploited. So, this is not just for the sake of reducing greenhouse gas emissions, but there are technologies where you can use the methane and save spending money on other kinds of fuels and power sources. So there's an economic rationale here, which I think would help with any transformation.
Do you see? I mean, I think I don't know if you're able to sort of say what the figures are, Andy. I think because you've done some figures around this, but are you able to put a few more numbers to that economic sort of rationale, sort of in a wider sort of context rather than just on an individual farm?
Sorry, lost control of my mute button there. I think so. The question was really about what could be done to stimulate and to move forwards, if I'm correct. So I think if you step back and say, well, where would it be advantageous for this gas to be used? If you look at most of the communities where these farms are, they tend to be at the end of long electric lines, which are quite flimsy, and electrification directly on the farm is going to be hard work or incredibly expensive because you need to massively reinforce the grid. This is an energy vector that is currently being deleterious to the environment, potentially people's health, because it does have health impacts of breathing methane. So if we stop this getting into the environment, then the reality is you generate funds on the farm which allow other things to happen. And the reality is that if we get initially the money into the research that demonstrates the benefits of that, they're already the first step would be to use that energy on the farm to reduce other inputs, and there are companies already producing, for example, gas-powered tractors, which would allow you to use it directly on the farm. That's interesting because it changes farming and it changes thinking about food, the economics of food production, because currently farmers and food producers have no control over their costs, as we saw recently with Putin's impact on gas and electricity prices and oil prices scooting up and down, and they have no control over their gate value of their product. Now, the reality is this breaks the link on their costs, because the reality is if they compare their farm with their own waste product, then you've changed the economics of farming, which changes the economics of food, which gives farmers a lot of space to do all sorts of other things. So I really feel that what's happened in the past, and I've seen it in other areas of technology development, is people want to give pots of money to one or two subjects, and that's important. But the reality is we need to understand and do a lot more research on A, what the opportunity is, and B, how that can really impact with stimulation the switch from where we are now to wider benefits, which could include the change of the economic model for farming in the UK.
Have you calculated at all, on a national level, if we took current emissions from our current sort of livestock sector, have you calculated how much energy that could actually generate?
We have done some early doors calculations, and the number is staggering. But as I say, within the presentation, I gave you a rough figure for the value of a farm using diesel pump prices, £28,000 a year per farm. You multiply that by the number of dairy farms in the UK, that's a very big number. The most important thing is it's going into poor rural communities directly. So it's effectively like displacing that amount of fossil fuel and putting it directly into taking it out of the oil companies' hands and putting it directly into farmers' hands. It's the best form of levelling up that I can think of.
What would be the practical implications for a farmer, do you think, in terms of like creating the right infrastructure and hooking up to the energy network? What would that sort of look like?
Well, first of all, they need to ensure that that they have a slurry collection system, that they minimise the loss of the gas on the way into the into that slurry collection system, that the gas is then covered, processed on farm. If we've mentioned Benjamin already, who are members of AFIR. There are companies now like them, and they are leading as far as in this field, who could facilitate that conversion.
There's a question. Well, there's a comment here from somebody called Charlie Bauer related to that. I don't know if Andy, you're able to help with this. He says there's a very long way to go on the CAPEX and OPEX, I don't know what those are, of biomethane upgrading equipment before making methane capture at a small scale on farm a widespread reality.
I don't. Well, there is more work to be done, but I wouldn't necessarily say there is a long way to go. There are companies operating in that space, like Benjamin, who have a business model that would deliver returns in a reasonable time. What's needed from sort of the government side is the CapEx investment through maybe grants or something, which would allow that to stimulate that process.
Okay. Yeah. So it's on the web. Yeah.
I was just going to come in and say we've got a long-term trend of sort of structural concentration and consolidation in the dairy sector. So in England in 1960, the average herd size was 21 cows. And in 1990, it was 60 cows. And now it's more like about 150 cows. So, dairy herds are on average becoming larger. And so over time, you're getting a concentration of production on a smaller number of farms for bigger herds. So this might not be something that it would be more of a challenge on a small beef farm, for example. But in the dairy sector, we're seeing production becoming ever more concentrated, which I think means that is less of a challenge, that scale issue over time.
Mm-hmm. There were quite a few questions about what this means for how we sort of look at extensively intensive livestock systems. What are the implications for this? I mean, lots of people are asking, does this mean, which is likely to emit more methane given what you're looking at, and also, I guess, how would turning that methane into energy sort of impact the sort of the calculations, the emissions, sort of net emissions?
It's quite interesting, this point, I think, because in a lot of the public and sort of scientific and policy discussions around agri-food system transformation for net zero, there's a lot of interest in regenerative farming, and intensive farming is sort of seen as a fundamental sort of problem for some people, and we're going to need to have more mixed systems and that sort of thing. I think on this particular issue of sort of economically viable methane capture of slurry pits, that is an emissions reduction strategy which fits with a relatively intensive and sort of large scale model. Now, there'll be people that will question, whether this trend towards the structural consolidation in livestock farming is something that can just be left to its own devices and sort of market forces. It might be, and this was a debate in the 1980s, that there are some water catchments where there are just simply too many dairy cows in them. And certainly when you look at poultry sector, that's the discussion at the moment around the River Wye, is that 20 million chickens is too many chickens in one river catchment. So there is a more fundamental sustainability question about how livestock are organised and the environmental sort of absorptive sort of capacity of catchments and localities, which is sort of a big question, but it's kind of to one side on this particular issue about technologies for reducing emissions from slurry pits, which in a sense helps reduce methane emissions, but within the current technological model.
In relation to that, there's a question here from Heather McCarman. How do we estimate the emissions on the rising number of pasture-based beef systems accurately?
So in the inventory around manure management, there is a load of stuff about, what is the system, I think how much time do the animals spend inside or not, that kind of thing. That data can certainly go into tier 3 level sophistication, but I think there's some of it in tier 2. There's certainly the number of animals are broken down by slurry systems and farmyard manure systems and other sorts of systems. So that is factored into the national calculations at the moment.
They're factored in at a very low percentage level of the maximum amount. So if you look at the equation, basically it calculates the first part, the maximum amount, then discounts it. The discount level for animals in pasture is very high indeed. As we move forwards, you would perhaps use the techniques you're developing for looking at the pits to go and measure those and understand that in more detail.
There are quite a few people sort of in the chat talking about biochar. I don't know if this is something that's sort of relevant, Andy, that you could say something on at all.
Well, I think they've answered their own questions, actually. So, yeah, I mean, if you put biochar in, you might reduce the amount, but then you've got to make the biochar and you've got to supply it, and that creates all its own problems as well. So the reality is you could be using an awful lot of energy to create an awful lot of biochar to do it. I don't know, it's not my area. But there are methods that you could use for reducing its production in general. I think where we're coming from is the amount coming off is a lot more than we're estimating at the moment. So we actually need to do a lot more research in this area. So yeah, I mean, maybe that's part of the story. I don't know, but I was following those conversations, and it appears that they were effectively answered their own. So people who know more about it than I do.
What are the big sort of unanswered questions you think you're going to be taking forwards from here?
There's a question from David about the Cornish sites and the Canadian pits were covered. So has there been any monitoring done on emissions from uncovered stores? So that might be something to just think about and talk about, Andy. Does it make a difference if you put a cover on and then monitor?
Yeah, I mean, this is fascinating. I've spent the last 3 years trying to monitor uncovered slurry stores. They're very difficult things to monitor. There is an evidence in the public domain. Look at some of the American studies where they've used on very large slurry pits, where they've used drone methodologies in conjunction with NASA. The figures from the literature are a little bit all over the place, and more work on that needs to be done. If you take a view on all the various evidence that you can find, it would suggest that it makes very little difference. The other side of it is that and if anything, covering it reduces it slightly. It would be one of the pieces of evidence that, if you look at that. Again, we could do a whole thing on how you actually monitor the emissions coming from uncovered stores. It's part of the work AFIR is doing, and it's an ongoing program. it's a challenge. The techniques that have been used from the oil and gas industry don't work for a whole number of reasons. If you get an emission from a gas main, it's high pressure, it's pure, and it's buoyant. You get an emission from a slurry pit, it's coming out 60-40 with CO2. It's coming out diffuse, which means you're right at the bottom end of the sensitivity of the devices, and it's coming out barely buoyant. So it looks much closer to what you'd see in the bottom of a coal mine, for example. And the evidence from the coal board is it can take anything up to an hour to go up 2 meters. So until it sort of disassociates from the CO2, it doesn't actually go up. So trying to actually measure it's very difficult. So yeah, I mean, that is a massive area of research. Is something that we're actively involved in a number of projects in that space.
Yeah.
I can be quite quick. It's just I see that Laura in the chat has said at the moment there's not enough available information in the UK on how manure is managed. Laura, we know, is very heavily involved in the national inventory and doing this work. So that's it's interesting that she's flagged that up, and I guess we're hoping that by publicising this work, we're helping to sort of build a case for more work needed. And I see Pippa has also asked about solid crusts and the difference that they make. So there's lots of interesting questions that emerge from this, and hopefully by just sharing this kind of work in progress, we've helped excite a bit of interest. I see there's been quite a lot of good comments in the chat to draw attention to what looks to be quite a material issue and something that is potentially solvable if we can do more research and rather urgently.
So, I mean, I think this chat is a great list of people involved in this area. There's also somebody called Stephanie Race who says she's measuring methane in dairy farming systems in the UK, California, Oregon, and Wisconsin, and she's given her details. So a really good person to talk to there as well. I feel like we've covered a lot of different things, a lot of technical stuff as well. Andy, I wonder if you could just summarize for us the sort of top things that you would just like people to really sort of take away from this presentation, because there's been a lot of different sort of detail. Oh, you're on mute. Thanks.
That old chestnut. Basically, to date, to use Neil's phrase, that slurry emissions has been the Cinderella of enteric, that the evidence is building globally that that's not necessarily the case, and that but that if we do take this on and look at it, the technology is available and becoming available by which we can convert this emitting gas that's driving global warming, has health effects, into an economic benefit in areas where that money would be very beneficial, and that we need to do a lot more work in understanding how we measure the drivers, how the slurry is managed, etc., to improve that position. But I would say that companies that we've been working with and are active within AFIR, and if anyone wants to come and join us, then we're more than welcome. We are pushing towards more understanding all the time, and supplying equipment that can actively abate this emission into the atmosphere and turn it into a valuable resource.
Great, thank you.
And we're going to have a face-to-face meeting in Bristol on the 16th of May.
Yes. Go to the
I was just going to say to everybody, I'm going to put the link in the chat in a second for that. But thank you all, everybody, for coming. Thank you, Neil and Andy, for all of that. Like you say, lots more to still look into. There are loads of people who've come today who are doing some really interesting work. So we'll try and kind of collect that up and maybe share it around if that's okay. So if today, as Neil said, if today has been useful, AFN and IFEAA are hosting a deep dive into this topic in Bristol on the 16th of May. It's an all-day event with speakers throughout the day, including Neil and Andy and researchers from Rothamsted, Royal Holloway, local government and industry. So I'll put a link in the chat in just a second. Our next webinar as well will be on using beans to test systems thinking for food transformation with John Ingram and Gerald Midgley. That will be on the 8th of May, and I'll be emailing around about that shortly. So in the meantime, if you want to browse our back catalogue of webinars on YouTube, you can do so. There should be a link that I've just sent around as well. And do get in touch with me or Neil if you have a suggestion for a topic. So thanks all and see you soon. If you just hang on 1 second, I will put that link for the 16th of May one in the chat. I'm just going to stop recording now though. Thanks everybody.